Good morning, everyone. Today we're looking at Unit 7, Lesson 4, Properties of Circles. So we're going to shift gears a little bit with our geometry unit. We've been focusing on area, surface area, volume, kind of all those measurements of space of 2D and 3D shapes. And the next two lessons are going to focus primarily on circles and different properties of circles and how those properties can help us determine certain measurements within the circle or around the circle. Okay, so some property of circles to be aware of. Kind of talk about these and highlight them as we go. So the circumference, okay, the circumference is the outer edge of the circle. It's the distance around the circle, and also it's our perimeter. So with most 2D shapes, we just say perimeter when we're talking about the distance around, but for a circle, we talk about the circumference. Okay, diameter. So our diameter is the distance from one edge of a circle to the other, passing through the center, right? And we've looked at this and its relationship with radius for years now, even back to grade 7 and grade 8. So the distance from the center of a circle to its edge. So the radius is always half of the diameter. All right, I'm going to look at the other side of the circle right now. We're going to talk about what's an arc. So an arc is part of a circumference. So if you look here at an arc here, you can see that it's part of the circumference, part of a line that going around the circumference, but not the whole thing. So we're going to talk about today, how do we calculate just a portion of that circumference? And we should be thinking about, if we're trying to find a piece of a whole, then we're going to try to take a fraction of that or a percentage of that. So just have that in mind when we're talking about an arc, because it's basically just a portion of the whole circle. Okay, the sector is the area enclosed by an arc and 2 of the radius. So if we look here, we can see that we have a radius, if we're just looking at the sector, right? We have a radius because it goes from the center to the edge, and then another radius from the center to the edge. And the sector is the area of that pie-shaped piece, basically, that you've cut out, that's formed by those 2 radius and the arc. All right, the next thing we have is a chord. So a chord is a straight line joining any 2 points on the circumference of the circle. And you can see, does not go through the center, right? The chord is connecting any 2 points on the circumference, but it's not going through the center, because if it did, that would be our diameter. Okay, the next thing is your segment. So again, your segment's going to be related to that chord. So the chord we have here is going from any 2 points on your circle. So our chord is going from this point here to this point here. So it's connecting these 2 points of the circle. And then your segment is just, again, the area. So it's similar to a sector, right? It's the area that's formed between that chord and the arc there. Whereas your sector is the area formed from the arc and 2 radiuses, or radii. Okay? And then the last thing I wanted to touch on is what's a tangent line. We kind of covered all the stuff that's inside the circle. So your tangent is a straight line that touches a circle at 1 point only. So if we follow this tangent here, you can see that this tangent touches the circle, but only at 1 point, doesn't touch it at 2 points. Which brings me into my next point. This diagram, I looked up diagrams. I couldn't find one for one more description you need. Okay, so one more property of a circle we're going to talk about, and this is called a secant. Pardon my not straight line, but it should be straight. So a secant is similar to a chord. I'm just going to call this a secant. The difference is that it intersects 2 points. Okay, so our secant is a straight line that, sorry, my pen's being fidgety, intersects a circle at 2 points. Right, so our tangent intersects at 1 point only, but the secant intersects at 2 points along that circle. Okay, so just one more criteria for you to be aware of. All right, so we're just going to talk about some of the measurements that we're going to start exploring. So in a circle, the central angle, which is theta. We've been talking about the angle as theta quite a bit, and I'm going to put it in our diagram here too. So my central angle is theta, and the radius is r, right? So if we're talking about our radius, which I'll put here on this AB or AP radius, we're going to represent that with r, and our central angle we're going to represent with theta. So a central angle is formed by two radii or radiuses of a circle. So you can see I have a radius here, and I have a radius here, and those two together are going to form what we call our central angle. And it should make sense because the radius are at the middle of the circle, so the angle formed by two of them is going to be that angle in the middle or in the center of the circle. Okay, another angle that's formed by two different line segments is called an inscribed angle, and we're going to look more at these on another day, but so an inscribed angle is an angle in a circle with its vertex on the circle. So this is essentially two chords, right? So our vertex is here on the circumference of the circle, and then it's going to point B, and from point C it's also going to point A, right? So those are essentially two chords, and the two chords form that inscribed angle. Okay, so we could represent this with a theta as well, or some other angle measurement. So we're going to talk about how do we find some of these things we've been talking about. So the first thing is that length of the arc. Remember that length of that arc is up here. So we're talking about how do we want to find that? Well, we should think about that it's part of the circumference, right? It's some fraction. So we know that, I'm going to put A for arc. We know that if we're trying to find a fraction of something, we just take it over its whole. So we're going to say that theta, which is my angle, divided by 360, right? Because we know the entire circle is represented by 360. So the arc is going to have some angle that's a fraction of that 360. So we'll put theta over 360, and then we're going to multiply that by 2 pi r. And this 2 pi r represents our circumference. So if we're wanting to find a piece of our circumference, we're going to multiply it by a fraction of whatever is being created there with that angle. Okay, that central angle. Okay, the area of a sector. So this should make sense to you as well. We're going to again take a fraction based on that angle, so theta over 360, and we're going to multiply it by the area of the circle. So pi r squared times, again, whatever the fraction that's created with that central angle. So that represents area. Okay, the area of a segment is a little bit trickier of an equation. Oh, and this should be a capital A. So we use our capital A's for area, and that lowercase a is for arc. Okay, so area of a segment, again, I'm going to use that capital A. This formula has a proof, I'm sure, not one we need to go through. But if we're trying to find an area of a segment, and remember the segment is up here, right? It's the area formed by an arc and a chord. The equation is 1/2 r squared, and it's going to be multiplied by pi over 180 times theta minus the sine of theta. Again, where theta is your central angle. Okay, so don't worry too much about the proof of that one. We're going to go through actually calculating some of these things. So determine the length of the arc of a circle with radius 8 and central angle 110. So we know that our theta is 110 and our radius is 8. So if we're trying to find the arc of a circle, I'm going to write down that equation again. So that arc of a circle is theta divided by 360 times 2 pi r. So I'm just going to plug in those values I have. So my theta is 110 over 360. So you can see that makes some fraction of our circle, times 2 pi times 8. Okay, and if we calculate all that, we should get that the arc is 15.4. And I just want you to remember that this was in meters. All right, let's look at some more examples exploring now the areas of the circle. Okay, so a circle has radius 12 centimeters. The central angle of a sector of the circle is 52 degrees. Calculate the area of the sector. So let's write down what was provided to us. So our radius was 12. Our central angle theta is 52 degrees. And they're asking us to find the area of the sector. So I'm just going to go back and look at what's that formula for area of a sector. It is theta divided by 360, right? That fraction times our equation for area, which is pi r squared. All right, so we'll plug in that information. 52 over 360 times pi times 12 squared. And when you calculate that, you should get 65.3 centimeters. And if we're talking about the area, remember we need square units. Okay, one more example, and obviously, as you can imagine, we're gonna test out that last equation we learned today, which is the area of the segment. So a circle has a radius of 4. We are to determine the area of the segment, so we'll write down that equation again in a second, if the central angle is 62.5. So again, the area of a segment formula is a long one, 1/2 r squared, and then in brackets, we have pi over 180 times theta minus the sine of theta. Okay, so if we were to calculate that, we're going to plug in all the things we have here. So 4 squared, pi over 180, again times our theta, which is 62.5, minus the sine of 62.5. Okay, and when you're calculating this, don't forget about your order of operations. So we should calculate our bracket first, and just so that everybody is comfortable with it, let's calculate our bracket together. So I'm going to leave this stuff outside my brackets alone for now. And I'm going to start with calculating what's pi divided by 180. So if I do pi divided by 180, and then multiply that by 62.5, so that first piece is going to be 1.0908. I'll just do 3. Okay, and then I'm going to minus from that the sine of 62.5, so I'll calculate that as well. So 0.8870. And I'm just going to keep on simplifying that bracket. Actually, you know what I will do? So we can say 4 squared is 16, and 16 times 1/2 is going to be 8. And we'll multiply that by the difference of what's happening in that bracket. So that 1.098 minus that 0.8870, we should get 0.2038. Okay, and then finally, if we multiply those values, we should get 1.63. And again, we want to make sure we put on the units there, so that's inches squared for area. All right, so our lesson today is looking at those 3 measurements of a circle. So can we calculate what the length of an arc is, and then the area of a sector, and an area of a segment? So you guys should practice that on your own now in the practice questions. And that's it for your note for today.